It's 5 o'clock.
Hello, sir.
Hello.
Yeah, I am Sagar from 60.
Hi, Sagar. How are you?
Fine, sir. So, maybe you saw the Word file was what we sent to you.
Yes, I have seen the files, and I also watched the videos. They were very helpful.
Okay. So actually, we are starting from the team water broom making machine, right? So let me introduce the team
Okay.
first, and they will directly suggesting what they have the queries and all these things, right, sir?
Okay, so let me say a couple of things
Yeah.
before we start.
Okay.
We have an hour together, right?
Okay. Yeah.
Right. Okay. And then, so the process is we are going to go through one by one the teams.
Yes, sir. One by one the teams. We have total 5 teams.
Okay, excellent. And in terms of my own background, I just want to say that I am an engineer, but not a mechanical engineer. So I'll have but I do know some of it. I have some thoughts on it, and so we can share what I know. Okay?
Okay. Sure. Sure. Sure, sir.
Right.
Okay. Team.
Good morning, sir.
Hi.
Hi,
Uh, Good morning, sir. I'm Akash.
and I'm Rituja, and we are going to present our project, like the broom making
Okay.
thing. Yeah. So
Okay.
I hope you have gone through the videos.
Yes, I have.
Yeah. So our social problem is broom making. The
Yeah.
broom makers, what they do is they use their hands. So broom making is a manual
Yeah.
process. So what they do is they take leaves and they thrash it on the nails to
Yeah.
tear the leaves apart to
Yeah.
make that broom bristly, to get that bristle touch. And what
Correct.
we have done is we have devised a mechanism that will replicate that movement. The movement of the broom
Yes.
thrashed on the china, that is the nail assembly.
So what the
Yeah.
process is, the nails are there, and then you hit the broom on the nails, and then drag
Yeah.
it so that the tearing process takes place. So
Right.
what we have done is the same motion we have done it using a 4-bar mechanism, and it follows
Yeah.
the curve which is on the same thing. The path followed by it is similar to what it is being done right now by hand.
Yeah, so it's like a
Yeah.
paw of an animal tearing the flesh apart. So same principle
Yeah.
over there. Yeah.
So in this case, you are reversing one aspect, right? You are instead of the broom moving, now the nails are moving,
Yes,
Exactly.
yes, sir.
right?
Exactly.
Okay,
Yeah.
right.
So
And so so I have seen I have witnessed broom making in villages, sort of people doing it manually and so on. So I also am familiar a little bit
yeah.
with that. Okay, so go ahead.
Yeah, so we went to the field, that is, we went to those broom makers with our equipment, and we
Yeah,
tried asking them like whether this is acceptable to you. So they came up
yeah,
with a few suggestions.
yeah,
One of the suggestions was what we can do is we can introduce a pedaling mechanism, a pedaling with the help of a leg.
yeah,
That was one
yeah.
thing. And the second was if we can make two broom manufacturing possible.
Since the
Yeah,
workers over there, they make two brooms simultaneously with both their
yeah,
hands. So they make two. So that the thing, if it is done using the our prototype, it will be good.
yeah. Okay, I'm writing notes,
Yeah,
so
yeah, sure.
don't let me distract you.
Okay.
Yes, sir.
So
Yes.
those were the two suggestions they gave. So currently we are in the next process. Like we'll be going over through their suggestions and then we'll be making those changes accordingly in our prototype.
Yeah.
Exactly.
So so let's see. So maybe I'll ask just for you and the other teams some similar set of questions. So that we have a process that emerges from this conversation as opposed to just a random walk,
Sure.
right?
Yes.
Okay.
Tell me a little bit about what are you studying?
I'm in.
Like
I'm doing.
research.
Okay.
Okay. I'm doing my engineering in chemical engineering
Yeah.
in Bangalore BMSc.
Okay.
Okay. And I'm a chemical engineering graduate.
Okay.
Yeah. So both of us are from
Okay, okay. So
chemical.
both of you are engineers. Okay, all right. Good.
And
So,
we also have a teammate, the third person, who has completed his bachelor's in mechanical engineering.
I see,
Yeah.
I see. And okay. But this is not the person I was seeing in the background, right?
No,
No,
he
no, no,
wasn't.
no.
Yeah, yeah.
He is
Okay.
right now talking.
Okay. So, uh, so ultimately, with this uh, project now, what are you going to try to sort of maximize or minimize or optimize, or what is it ultimately? What
See,
have you found?
the thing was, while hitting the brooms, the workers face a lot of trouble in their shoulders. So it is a
Yeah. Okay.
continuous process, and they get a lot of
Yeah.
shoulder
So there's
injuries.
an occupational hazard.
Occupational hazard, we can call it.
Yeah, yeah. So we're trying to minimize occupational hazard is one,
And
Exactly.
also,
right?
while hitting the brooms, in case the brooms slip, the hand goes
Yeah,
and hits the set of nails over there, and then it
yeah,
causes a lot of wounds in the hands. So
yeah.
also this might prevent the wounds from happening.
So safety is the other.
Safety is the other
Safety is the other
aspect.
aspect.
You were trying to maximize safety,
And
minimize
minimize labor.
occupational hazard,
Yeah.
which is sort of probably chronic, a long term
Yeah, and
Shoulder and back problems.
yeah,
tennis elbow or whatever,
frozen
swimmer's
shoulder.
shoulder, whatever. Yeah.
Exactly.
Okay. Um, and how about sort of the efficiency of the process itself? Does it matter?
It does.
Yes,
Like
yes.
how many rooms you make in a day and all that?
Yeah, it is like they generally produce about 50 brooms per day, um,
Yeah,
and then if our prototype makes it more than 50, that would be good.
yeah. I see. So okay. So the first question was, what are you trying to maximize or minimize, just in terms of our framework, right? Second question, what are you competing against? So you're competing against about 50 brooms a day,
Yeah,
Yes, exactly.
type of a target, right?
yeah.
Yeah.
Uh,
With
and
with
your
the with
yeah,
the same efficiency. I mean, the tearing that happens with the hand, that should be the same in our case also.
yeah. So your quality
Quality
in
wise,
some
yeah,
Should be
right.
the same.
it should be the same.
Or
Same,
same
Okay.
or more, but not
better.
less.
Same. All right. Sure. Sure. Yeah. Yeah. Um, uh, And in your current designs, I looked at your current design, which there was somebody pedaling on a bicycle, right?
Exactly.
Yeah,
That was a different. That's a different person.
yeah,
Yeah.
And then there is the person who is actually
Holding the broom.
pushing the broom through.
yeah.
Yeah. So what we've
And
done is we have developed a design that will move the crank from one hand and the other hand we can use to rotate the broom.
That's what the correction we are thinking right now.
Yeah.
And
I see.
we also thought of a process in which a person can pedal using his legs, and using his both his hands he can make two brooms simultaneously. So there are a set of nails on either sides of the moving shaft, and then
Yeah.
two brooms can be made simultaneously. So we are thinking on which one to go for right
Yeah.
now.
Okay. Whoops. I Can you hear me?
Yeah,
Yeah,
yeah, yeah.
sure. Yeah.
We can.
Hello.
Yeah, yeah.
We can.
We can hear
I
you.
cannot hear you. I don't know if you can.
Can't hear us.
कैसे चल रहा है? चिल है, कल के लिए सही है।
नेक्स्ट से नहीं है
क्या? सीजन जो मिल रहा है। अगर इसके बाद नेक्स्ट किसका है? क्या किसका? डिस्कशन।
Hello?
Uh,
Hello. So,
so can
Yes,
you
sir,
hear us?
please. Yes, I can hear you now.
okay.
वीडियो स्लो है।
Um, is video okay, or shall we
Um,
leave video out, or what?
Okay.
so can you see
Yeah.
us?
Yeah.
Yeah.
Yes, yes, I
Yeah.
can see you. Okay, so I think so. Uh, um, Okay, so I understand the challenge. I think it's a nicely framed problem. Nice work and sort of going and working with the community, and that is really important.
Yeah.
What I see is like I had two thoughts in mind. Um, so the one question is that we would like to answer, which we don't have to answer right now, but for all of the teams, I think we should try to answer is that what is our central hypothesis um, in terms of solving this problem? And I think what I see in your case, that your central hypothesis is that the mechanical movement. So you are reversing this principle, and the movement part you are making it mechanical.
Yeah.
Exactly.
Yeah, and so that's interesting. That's an interesting reversal of the problem. I think in some ways it sort of overcomes the fundamental constraint of a human being trying to do that over and over.
Exactly.
But there may be like an interesting there's an interesting tension here that one would have to work through. The efficiency is kind of in some ways easier to achieve. You can modify the mechanics of the nail structure.
Yeah.
You can modify the shapes of the nail,
Okay.
and you could probably modify the efficiency of the flywheel so that it operates faster,
Exactly.
and so on. Um, uh,
So we are looking
but
into all those
yeah,
technical details like the nail
yeah,
shape, the spacing between the nails, the
yeah,
crank and sprocket distance.
yeah.
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 So
The one, I think the tension here is that in achieving those efficiencies, are we actually uh, are we actually increasing safety, or are we reducing safety? Because now it feels like if there was an accident now with this new system, it could be much more fatal, because this thing just comes and slams onto the um,
Broom.
broom, right?
Yeah.
exactly.
So I was wondering if there was any way to sort of again, there are cost constraints here, but something very simple which mechanically obstructs the hand from getting too close.
Yeah, we are planning on it. What we have done is we have introduced, like, there is a slant over there. That broom is placed at an angle. So when you
Yeah,
put a broom over there, the
yeah,
the movement is such that it will take that those nails will pounce on the broom and it will move away from
yeah,
that hand. So even if the
yeah,
hand goes in there, it will be dragged away from those nails. Like,
yeah.
yeah,
Like
But
uh, when
yeah, sorry.
the traditional method in it, if the broom just slips away from the hand, the hand might go and hit the nails. But now what's happening is,
Yeah,
since it is moving away, so that
yeah.
thing might be avoided.
Yeah, but if the hand itself sort of slipped under, so I was wondering, for instance, in medicine, I mean, when this surgical equipment are made, since there is a great concern for particularly in operations that relate to neurology and such, there's a great concern for you touching nerves that you shouldn't be touching and so on. It uses some kind of a mechanical obstruction uh, for your hand to even get there. So for example, if your device had some flange
partition
like
like thing.
this, which would have you put your hand through it. I mean, broom through it,
But not the hand.
but you're not the hand.
Yeah, exactly.
Okay.
Yeah.
And that way, your hand is
Safe from the nails.
safe from the nails. Or other way out is that there is some metallic. So imagine that this is the machine where the broom is on this side.
Okay.
uh, there is some metallic cover underneath the hand goes.
Okay.
So and then and then the hand is obstructed from it. So you don't
Okay,
have to
okay.
have a very fancy thing, but something
Right.
that mechanically prevents the hand from. The other thing I thought was that this separation of somebody holding a broom. So there are two solutions you can think about. One is that somebody holds a broom and somebody else pedals.
Yeah.
Uh,
Ergonomically, that's simpler
yeah, but we would not
because
prefer that since
yeah. But if you don't prefer that, then this whole question of ergonomics of in the current process, the manual process, the ergonomics are that you have a shoulder pain and so on.
right.
But if you have this awkward, you'll have to really design such that this person can actually sit up and
Pedal.
pedal or because otherwise they get into like, see, this is the same problem as this,
Okay.
right? One person is, I mean, one hand is shoving the broom, other hand is doing this thing. And
Exactly.
people will learn it. I mean, of course, human beings are amazing, right?
Yes.
But it may create other
Other problems.
ergonomic problems that one would have to measure,
Okay.
Exactly.
Yes.
So
right?
we are.
And the third thought I had was that I don't know how you're thinking about this, but uh, you have this is a very interesting solution. That the one you have is an interesting solution because it has a lot of room in terms of modularity.
Okay.
Like, what do you design? Do you design that pedal plus the machine, or do you design machines that plug into existing bicycles, or uh, so that people can, they
You.
need the machine, they don't need the bicycle.
Bicycle. Exactly.
Right.
Yeah.
So what part of it do you actually give it to them?
As a
Is one question in terms of the modularity. So
Yeah. So what what
that's
we are planning to do is we'll
yeah,
have the pedals, and on top of it we'll put a seat. So what will happen is that person will sit on it, it will pedal, that person will pedal,
yeah,
and that nail mechanism will be shifted up so that
yeah,
he just has to move the brooms.
yeah.
But
But you would also, you are going to do the whole machine. Current
that
idea
is
is that you do the
no, no,
machine,
no.
right?
That is the second version. That is where the problem arises.
I see.
Because if we do
I see.
this, it will make the from that tool it will shift to a machine. So this becomes a huge machine, and we don't want
Yeah.
that because then comes the storage
I see.
problems and transportation problems.
Right.
those
Right. Right.
those workers actually stay on the sides of the road. They don't have a home as such. So
Yeah.
keeping those machines itself would make it a problem. So we
Yeah. Exactly. Yeah. Yeah.
Yeah.
And this is sort of, we are thinking about one per village type of a deal here,
Yeah,
right?
but what happens is if we devise a tool like that, then it will be like four or
Yeah.
five families live around an area. So it will be better to make
Yeah.
a small tool which a family might use instead of devising a machine for a
Yeah.
whole village.
Yeah.
So that will
Right.
empower them more, is what we felt.
That's right. That's right. That's interesting. That's interesting. I don't know what the incentives there are. I mean, if this has to be done commercially, can they internalize their benefits? And in that case, do people? So the question is this a do-it-yourself industry, or is this somebody selling brooms? What I have seen is that it is somebody selling brooms.
Yeah, it is.
Because people don't. Yeah. So I mean, it may be in terms of its economic viability. It feels like it may be better for somebody to do it as an entrepreneur
okay.
rather than homes to do it by themselves, because this notion of skills get distributed. No, not a single individual has an incentive to provide it to people, and so on.
Right.
So it feels like that. Yeah.
Okay.
By the way, I want to watch the time because we
Okay,
only
okay.
have an hour.
Yeah, yeah.
Yeah.
So thank you for your suggestions.
Uh,
We'll be going as in the second group will be coming now.
Okay, great.
Yeah.
And all the best. And always feel free to email. You have my, I don't know if you guys have my email.
Yeah,
we
yeah.
I'm
we'd get that
Chintan
from
V.
We'll get that
You
from
got it.
our.
coordinator.
Sure. Thank you.
Thank you, sir. It
All
was a
right.
pleasure talking to you.
Yep. Great. Great work.
Yeah.
So now we are going for the second team, which is a load carrying device.
Okay. Oh, yes. Very good.
Hello, sir. This is Aniket.
Hi,
I'm
Niket.
I'm doing mechanical engineering from BITS Pilani.
Okay.
Hi, and this is Rashi. I'm doing mechanical and aerospace engineering from University of Texas at Arlington.
Okay. And
Yeah.
then I saw you, Aniket. You were carrying that thing.
Yes, sir.
Yeah. Yeah. Okay. Yeah. Nice. Okay. Go ahead. Go
So
ahead.
we're
I thought, by the way, this is a very fascinating problem, a very hard one also.
Yes, sir.
Please go ahead.
we're trying to design a load carrying device for construction site workers, the workers
Yeah.
that usually carry bricks or cement on their head.
Yeah.
So the
Yeah.
conventional practice is that workers who carry bricks would carry it on their head using a wooden
Yeah.
plank, and then they would place bricks like to, two bricks at a time,
Yeah.
and then they'd go up to like 12 bricks.
Yeah.
And for cement, they would just carry the whole.
The cellular device which carries, which on which they place the all materials,
Yeah.
and they place it
Yeah.
on their head.
They place it on their head, right?
Yeah.
And these are generally women. A lot of them are women.
Yeah, women.
Yeah.
For bricks, it's usually the men, and for cement, it's usually women who carry them.
Okay. Okay. And so uh, and what kind of problems?
They usually complain of back pain
Yeah.
and neck pain and shoulder
Yeah.
pain because that's where the most of the load comes.
Hmm. Hmm. Okay. And so let me ask the same set of questions.
Sure.
Just were you in the room when the first team was going
Yeah,
through?
yeah,
Yeah.
Oh, you were there. Okay,
yeah.
so that's good. So I just because everybody's nice and quiet, I don't have a sense of how many people are in the room. But what are you trying to maximize, minimize, or optimize?
Right now there is a problem of safety. Like they don't have any tool for safety. If there is unbalance, the structure would fall upon and they might incur any medical injury. So we are
Yeah.
trying to give them comfort and safety with weight distribution on different parts of the body.
So because presently they complain mostly of neck pain and back pain, so we're trying to relieve stress from those areas
Yeah.
and
Okay.
increase
So you're
efficiency at the same time because currently they carry 12 bricks at a time. We're trying to take it up to 16 or 20 at one time.
yeah. Okay. Yeah. And so okay, so you're trying to maximize safety and comfort, and you're trying to increase efficiency of the process also. Okay. Are there any fundamental constraints to achieving that objectives that you are observing? Okay.
Constraints as in construction sites
Uh,
usually here they have uneven surfaces. So when we think about design
yes.
that as a trolley, so the workers could just like put everything in there and take it.
Yeah.
That's sort of a constraint because it's an uneven surface, so the trolley might veer away easily.
And they
And they
Right.
also have to take it upstairs, so there's a lot of up and down movement, and that's not possible with a trolley.
Yeah. Yeah. Okay. So uneven surface definitely is a sort of a fundamental constraint that prevents a certain class of solutions.
Uh,
video.
Video. I'm low offline right now.
हाँ सर हम हमारा वीडियो ऑफ रख रहे हैं
वो भी ऑनलाइन दिख रहा है.
Let's say.
Hello.
Yes,
Hello?
sir.
Yeah. can hear you. Okay, so that's great. And so I looked at the device. So currently your central hypothesis seems to be that the load is distributed over more evenly
On head and both
And
shoulders.
shoulders.
on head as well as both shoulders,
Yeah.
or
Well, we're trying to provide a support through the main flank on the shoulders,
yeah.
so equal distribution of weight on head and shoulders.
Mm. Okay. And what are there, is there anything you're competing against? What is the competing solution? Yeah.
Competing solution would definitely be how effective a trolley is in the same scenario.
Okay, that is if you were to design a trolley, but the existing solution is just carrying it on their head
So
and
we
carrying it on some kind of a plank for this
Yes.
cement yeah. Yeah. So I feel that this um, it, this is one of in all the five ideas that we're going to talk about today. I think this is one of the ideas which is sort of is a lifestyle type of issue, right? And the barrier to adoption um, initially may be cultural, actually.
Well, there's also a certain amount of resistance from the workers because they say that if you make the work easier for us, we're not going to be paid as much.
Yes. Oh, I see. That's very interesting. So there's an economic, there's a perception that there's an economic problem
Yeah.
also there. Okay. I was thinking that, currently if you sort of, in terms of just the design problem, if you were to think of this as not just the contraption that one is designing, but how that contraption plus the human um, physiology works together. So one is trying to optimize both together as a system rather than optimize the contraption.
Okay.
You may already be thinking like that, but because I think this whole question of terrain, uh, like if so some time ago I worked with a bunch of coolies on the railway station. What I learned was that they were working under multiple constraints, and these construction workers the same actually. There's a time constraint, there's a terrain constraint where when they carry this load, uh, they're actually balancing their body in order to compensate for the movement of the load, right? In order to keep the load, uh, 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 um, the central axis of the load
The
within a
center of
certain
gravity,
bound.
basically.
Yeah.
True.
So center of gravity and just the alignment of the load, and there the human being is so amazing at doing that to match that kind of efficiency, uh, unless one puts close to that kind of efficiency and also reduce the pain
Yeah. Because right now,
very visibly, or where you can actually at the end of the day feel that yes, I feel a lot better today because I used this contraption and I got the same amount of work done. Um, they, until that point, there's going to be this barrier to accepting something like this culturally also. Now, the economic problem itself, there may be ways to, in terms of the pilot or the sort of the shed market, it may be possible to go with builders who are more conscientious and say, hey, would you try this out for your workers? And then once they adopt it and others will follow, that will be the way out. But I think think, thinking of this as a system, the load plus person is sounds like the way to go about. And in that case, I think the one ideas that come to my mind, the contraption itself can have some spring type of component so that the lateral movement and the movement of can be compensated for. So this is exactly like a car suspension.
So where do you suggest
You
putting
know,
the springs?
what's that?
Where did you suggest putting up the springs in the whole system?
Oh, so I was thinking in the sort of, so you had the shoulder up
Yeah, we did.
in that rod. If there was a way to sort of put a spring, I think it would go closer to the load rather than closer to the person. But that's a hypothesis. One may, if one makes these rods with a spring at one end, you can easily tip it
Yeah.
to try both. So that's one thought that came to my mind. But it's very, in some ways, fairly culturally complex problem. So you would have to be in a very tight loop with the user. And like just a handful of them who are willing to try it, even for like 15 minutes a day, and just gather that data and rapidly iterate is, I think, going to be the way here. A fascinating problem, though. Very big, important problem. Yeah.
Thank you.
So, yeah. Any, so, and again, feel free to write.
Sure.
Yes, sir, sure,
Yeah,
sir.
we were writing down. Thank you.
All right, great.
Yes, sir.
All the best. Yeah.
Thank you.
Uh, Sir, now we will be having the next group, which will be the
Okay.
cactus fruit plucker, and they are also
Okay.
working on juice extracting. So, sir, this is the
Yeah.
group.
Okay.
Hello, sir.
Hi, sir.
Hey.
Hi. So I'm Parul.
And
Okay.
Shubhangi.
Shivangi. Subhangi.
Yeah.
Subhangi. Okay.
I'm Shubham. Hi,
Subham.
I'm Ganesh.
I'm Shreyas.
I'm Sharan.
Oh wow. Do you have a big team? Or all teams are this big?
No,
No,
only one.
we
We had
two
two
teams
teams
combined.
combined.
Oh, you two teams combined. I see. Okay. Okay. I thought the cactus has too many thorns. So okay. All right. Okay. Go ahead. So I looked at your video.
Okay.
Okay,
Yeah.
So
yeah.
tell me what are you trying to maximize, minimize, or optimize?
Yeah, so actually
Um,
the when we went to the field visit for the first time to see how these cactus fruits are getting plucked by the farmers and all, so we saw that they were facing a major problem in plucking fruits which are at very distant height, because
Yeah.
the fruits that are very low level and are approachable, they can easily pluck them using the stick and the container, conventional methods.
conventional method.
Yeah.
Just
Yeah.
tapping it
Correct.
and then
Yeah.
things get done.
Yeah.
But the fruits that are very far away and are not accessible from where their stick and container, they were not able to plug them, and most of the farmers actually leave them, and this actually reduces their earnings. So
Yeah.
And the upper part of the fruit, the upper part, where fruits,
Yeah.
where bigger and riper fruits grow, they don't
Yeah.
pluck them because they are at greater height and बहुत thorns होते हैं, so it's like they
And
ignore
do
it.
fruit grow far away to
Yeah.
protect themselves from farmers?
Maybe.
No, sir. I
No,
guess
it's
good
not like
fruit
that.
grow
No.
far away because it has been with the plant for a longer time, right? So it is much bigger and much sweeter.
Right.
Yeah.
Right. Okay.
yeah, so
Okay.
we'll start with the
Yeah, we
right.
have to
So
first first.
So we
you said
have
4 to 8 centimeters. Is that what I read in your? That's how big the fruit can get.
yeah, that's
Yes.
the
हाँ
maximum.
हाँ.
Diameter,
Yeah. Okay.
not
Yeah.
8 centimeter up to for you.
All right.
So we
So
have
I saw this. Yeah. Okay. Go ahead. Go ahead.
So we have made two prototypes for cactus fruit plucker. So
Yeah.
first one is this. So we have made this. This is a PVC pipe, and we have made this kind of cutter in here,
Teeth.
and
Yeah.
using teeth. So
Yeah.
can you see the teeth?
Yes, I can see the teeth.
Yeah. So also we have. Also we have used this part as well and made teeth here as well, so that we can plug the fruits which are not accessible using this part.
I
So,
see. Okay.
and we have also tested this prototype and it was giving good results. But the problem with this prototype was that the size of the hole was very large, and that's why the fruits were getting fallen out of the hole instead of going into the pipe where
I
it
see.
was supposed to get collected.
Yeah.
So that was the one problem, and apart from that, uh,
Yeah, and the teeth, we had two teeth, right? Upper part
Yeah.
two teeth. So they suggested, the user suggested that use one bigger teeth. So it would be much easier and much more helpful for efficient for plucking of fruits.
So one bigger teeth will be like this,
Yeah,
Like this
yeah,
and
only.
like
then
that.
yeah,
Yeah.
okay.
exactly. And then
Okay.
one would be like this. The down one would be
Yeah.
this. So
Correct.
yeah,
Correct. Okay. I think form a diamond. Yes.
yeah,
Okay.
yeah,
From a
exactly.
diamond kind of thing. And we also have a different design for the same fruit plucker, in which we
The
have
video was of that L-shaped
No, no,
plucker,
no,
no?
not that
No,
one.
we are talking about we had two designs, right? So you are
Yeah,
talking
yeah.
about the first one,
Right.
This one
this
video I
this
think
is
is
the
was.
the
second design.
the
So what
L-shaped
we
one.
have done in this design, this is kind of same like the first one, but the difference is that we have used a spring system here to have given a handle at the bottom. So when a
Yeah.
farmer is using this design, and we have also applied cutters here. So when you push the handle from the bottom,
Yeah.
so when
Yeah.
you
Go ahead.
just a second. Yeah, so when you push the handle from the bottom, it actually closes and get back again. So because of the
Yeah.
spring only. So it was giving an edge that the fruits were not falling out of the pipe. But the bigger problem with both of these
Yeah.
prototypes was that the number of the
We'll
fruits that they were plucking were actually less than their conventional
right.
methods. So that was the big problem.
Yeah, it was like this. Here we had two blades, right?
But
Wait,
Yeah.
yeah.
So down there is
Right.
this
Okay.
thing.
So this, yeah.
pardon,
Sorry.
sir?
Please go ahead.
What?
What?
Please go ahead.
Oh,
There's a there's some delay. Go ahead.
Okay.
We are explaining this thing.
So yeah, there was one problem ki there's blade over here, so sometimes the fruit used to get damaged,
Yeah.
right? Because half
Okay.
fruit went
Right.
inside and
Right.
then just get
Right.
damaged. So there was this only problem. Yeah.
So you said that they the number of fruits that can be plucked with this is less than their conventional method.
Yeah.
Yes.
Yeah.
it's
But
less,
but
but
it
it's
sounded like, yeah.
so it is
Sorry.
less, but it is comparable. And the thing is that conventional method they have lots of practice with it. This in the first trial is
Yeah.
comparable to the number which they collect. So we believe that if they have more experience with the device, they could at the current prototype they could pluck even more fruits than what they do right now. He vended. It was not my fault. Wrong video is
The
too
video
slow.
is turned off.
No, is it?
For connection point of view, first video close रखना चाहिए.
Maybe
Yeah.
I should do that.
Close ही है अभी close ही है.
अभी
क्या क्या समझाना है? और क्या समझाना है?
देखो तो.
मुझे समझ नहीं आ रही है, बोलने का मतलब लगा कि हाँ हो तो गया, आप क्या बताएं?
तुमको बताना जब मैं नया सोचा है.
अबे है ना.
Arey, we can do one thing na, Ashley na. We have told everything. Now we can ask his feedback. What do you
Based
want
on
to
this
suggest
thing,
now?
your feedback. Start करो. उसमें मत जाओ अभी.
Yes, sorry, we lost each other. Yeah. So you said that you were talking about the training, that without the training they're almost comparable.
It can't
Yeah.
be like training with
Right?
experience. Like after the third use, fourth use, I think they can be better.
Use of our new
Yeah.
prototype. Yeah.
And so better, so tell me the numbers. How many do they pluck
So
So
in
like they,
using their methods, they were able to pluck about 20 fruits per minute. And using our device, we were able to pluck around 12 to
12 for
15
Hmm.
fruits per minute.
and how many fruits are there to pluck in for a conventional farmer?
so actually there
It
are quite a
depends
number.
upon season. So
Depends
like
upon the season as
Right.
well as the distance they want to travel. Sometimes they
around
travel along around 20 kilometers. Sometimes they actually went till 50 kilometers to pluck the fruits. So
Yeah.
the more they travel, the more fruits
actually
they are
the
able to access.
amount of fruits they need, they have more than that. Means they have abundant of fruits to pluck.
Yeah.
he
The
told
point is
Okay.
that.
So
20
actually the
kg
So the
fruits
point
per
is that
bucket with
fruits
ball.
are actually not grown by them
Them,
only.
yeah.
It's actually grown on. It
As
is
a
actually as a
fencing.
fencing.
Yeah.
Fencing
They
So
they're growing in wild.
they're
yeah,
not
yes,
Yeah,
growing it.
yeah,
so
and
actually
wild.
the
Yeah.
fruits
Yeah,
growing
yeah,
in wild, yeah,
yeah, in wild.
like
It is used
roadside
as a fencing for their fields for different farmers.
it
or
grows
For
or
it grows
roadside.
very fast. It's basically used as a fencing because the plant and the fruits are
Yeah.
not approachable because of their thorns, and because of this reason, and also this grows very densely and grows very fast. For the same reason, it is used as a fencing almost
Yeah.
everywhere, and it also spreads from there. Like it started as a fencing, but it spreads by itself through water and other when it rains, etc. It spreads throughout the place, and you can find it everywhere in the deserts in these areas.
And when they pluck it, do they sell it or
They they
they
sell
what?
it.
make juice out of it.
Both ways.
They
Okay.
can
Some
sow
And
raw
this
fruit as well, and processed fruit as well.
the more
And
of the processed
Okay.
fruit.
And now there's a you mentioned juice, and there's a juice part of the story which we haven't heard. Are you
Yeah.
guys working on the juice
Yeah,
side?
Yeah,
so
yes
we
sir.
can
We
show you
have.
some fruits.
so actually, the first step which is required in this processing is about the thorns which are on the fruit.
अलग है नहीं हो,
Yeah.
अलग है नहीं.
Actually, the
So
fruits
these
have
are
the
this
fruits.
is the norm. This is the fruit that we plugged that day.
Okay.
So it
Okay.
has a very hard covering, and you can remove the covering and can get the pulp from inside. And when it is, and then the juice can be extracted from this. And it is very good biological and medical
Yeah, so
applications.
it has a lot of thorns in it. So the first step is to remove the thorns, right?
Yeah.
And then the outer covering is to be peeled, and the pulp उससे juice निकलता है. So yeah,
Huh.
that's it.
So now, oh wow, that sounds like a much harder problem than plucking. Okay. Um, so so let's deal with the plucking part first. There, it sounds like, I mean, what you're offering is there's really no in some ways there's no competition for it, in the sense that you're offering to pluck fruits that they currently can't pluck,
Yes,
Hmm.
yes,
right? Is
right.
that the
Yes,
value
yes,
Yeah,
proposition of this
yeah.
thing?
yes, yes.
Yeah, yeah.
That it should be able to. So you can use the conventional method for whatever you want, but for all the other fruits, but for certain fruits, uh, this uh, uh,
For
this
non-mission method,
contraption will be.
Used, yeah.
Sorry, you were going to say something at the back there.
Yeah, for the conventional methods, it is used only for the distant height at the lower height.
Yeah.
For long distance, up to
No, that's right. Exactly. Right. So this the efficiency. I think one thing. So one suggestion I would have is that it's a matter of how you sell it to people, right? You you explain the notion of efficiency as being not just the number of fruits picked, but the quality of fruits picked.
Yeah.
And so that story will have to be worked upon.
Hmm.
Uh, of course, you'll have to make the play with the various teeth and all that.
Yeah.
I think that's a matter of trying things out. So there, I don't think we need to discuss it. But I think it's going to be more about hey, you can do more with this rather than faster with this type of a.
Yeah,
I think
yeah.
that's one part of it, because I think people. um, I don't see us making an efficiency argument with them
Yeah.
on such a contraption. We should accept it if that's the limitation. Um, the but the juicer part, are you trying things out
Yeah.
here
So
in terms of yeah?
two things were developed. Can you take
Yeah.
that thing? So one thing we showed is that thorn remover. So
Yeah.
where in the conventional method they put fruits on the sand and hit with some
Yeah.
leaves of trees to clean that small thorns on the fruit, or they
Yeah.
put all these things in jute bag and then shake that to remove the thorns. So what we
Yeah.
had is plastic box. Inside that we have
Yeah.
kept a wire mesh, uh,
Yeah.
steel wire mesh, and on the top part of the box we have fixed two wire brushes, and we put the
Yeah.
fruit inside this thing and shake this box.
Shake.
So
Yeah.
that this prototype was developed as a proof of concept to check whether this thing works or not. So what we observed is this thing works, but they what they said is they want something bigger in size. They can't process fruits in this number like now and then like this. So they want
Yeah.
something of big size which will work to remove the thorns. And regarding fruit peeling process, we have made this in a plate. We have made different diameters holes
Yeah.
in this thing. So in conventional thing, they will cut a top portion of the fruit and then
Yeah.
peel the fruit using scissors, and the inside pulp they will use pulp with the seeds. They will further process to make juice or whatever applications. So here what we thought is that process is quite tedious. So just take the section of fruit and whichever diameter you can match, you keep the fruit on that and
Yeah.
press on this thing. So outside
Yeah.
peeling removes on the top and other part falls down. But this
Yeah.
thing we have not yet tested exhaustively with the farmers. We only performed here, so it worked, but we want to test it more with the farmers. How much difference this will make in the process.
Yeah.
So this is the part from our side.
Okay. So this okay. Okay, great. So this sounds like work in some ways work in progress. This side of the story, right? My suggestion would be to put a large fraction of your team on this problem,
Okay.
the juicer problem,
Okay.
and a small section of your team to experiment with the teeth
Okay.
of that plucker,
Okay.
and maybe one person of your team to work on the sales story of your idea,
Which
Which
I
story,
know.
of
sir?
Pardon, sir.
how the sales,
Sales story.
Sales.
that proposition of
Marketing.
how to, what are the various ways in which this can be pitched, what are the reactions you can get, and so on. Because I think yeah, but that's just one person on the teeth, and everybody else on the juice.
Juicing part. Okay.
Yeah.
Okay,
Fine.
all right.
Yeah.
So
Thank you,
let's
sir.
go to the next team.
Yeah.
Thank you.
Okay.
Thank
Thank
you,
you,
sir.
sir.
Thank you,
Nice
sir.
to talk to you. Thank you.
Uh, so sir, the next person is from the seed developer.
Yeah.
Yeah, so actually there are three person in the team, but because of this time difference of EST and IST, we are confused. So they're supposed to that the lecture is 7:30. So there is a one person at here right now with us
I see.
from the seed developer.
Okay.
Okay.
No problem.
Uh,
No problem.
Hello, sir.
Hi.
I'm Jannavi, and
Hi, Jack.
I'm pursuing my BTech in electronics and communication.
Okay.
Yeah, and the problem we are dealing with is SID Dribbler, our project.
मैं एक काम करता हूँ
also I watched it. Untitled Chapter. So the Chintan Vaishnav Untitled Chapter. हाँ
Hello.
Hello, sir. Yeah.
Yes,
The
sorry,
yeah
we got
yeah.
disconnected. I don't know why this is keep happening, but we're
So
back. Okay,
yeah,
go ahead.
we are dealing with seed dribbler. So
Yeah,
what we have to focus is on precision seeding. So that
yeah,
involves placing the seeds at precise space and depth.
yeah,
Well, nowadays in India, in many countries, farmers use tractors, but there are few
yeah,
people who still do it manually.
yeah,
So due to which they sometimes face health problems like hand aches or shoulder aches, all those things.
yeah.
Yeah.
Right.
So what we need to focus is on placing the seeds at precise space and depth. So if
Yeah,
you have seen our prototype,
I did see it.
yeah, yeah. So what was the problem with it was that there were many mechanisms involved in it. Depth was
Yeah,
right in placing the seeds, but
yeah,
when the farmer has to place the seed, he has to perform many mechanisms. Like first he has to move the dribbler, dig it in the
yeah,
soil, rotate
yeah,
the handle in order to move the extractor seed,
yeah,
extractor will, and then open the flap which is downwards. So he has to
yeah.
press the brake if you have seen the thing. Yeah.
There was this.
Yeah.
There was a tie
Tie.
that sort of
Yeah, right.
opened the flap.
Yeah.
Yeah, yeah.
So when for field visits, the farmers were quite happy seeing it. They didn't like give any suggestions, but we have to think in the long-term use of the dribbler.
So your concern is that there are too many moving parts for
Yeah,
it to be viable.
yeah.
Is
So we
that
want to make the mechanism little bit simpler in moving
yes?
the dribbler and placing the
Yes.
seeds. Yeah,
Right. So now dribblers seem to have a lot of prior art in terms of
yeah,
like the every agriculture
yeah.
university I go to.
Yeah, there are many prototypes designed before. We
Yeah,
had
yeah,
seen those, and those dribblers like were involved in continuous process. That means you have to just move the dribbler, and the
yeah,
seeds are placed automatically.
yeah.
Yeah, but we are
So
yeah, yes,
yeah, go ahead,
yeah, we are
please.
thinking of designing a dribbler which will be involved in continuous as well as in discontinuous method, which
Yeah,
means like sometimes the farmers have to perform gap filling. Sometimes the
yeah,
seeds don't germinate. So we want
yeah.
to design something such that the wheels
Okay,
are detachable
okay.
and the farmer can go to that place and dribble at that place because he can't move the dribbler along the seeds which have germinated.
Hello.
Hello.
Uh, so can you do one thing? Can you just can we stop our video from our side?
Hello.
Hello.
Yes, I can hear you.
Okay, just 1 minute, sir.
Yeah.
Um,
Okay, so you're trying to achieve ease of use.
yeah,
Um,
trying to make the mechanism little bit simpler.
Simpler. I mean,
Yeah.
simpler. Well, so
Well, what
I'm
we
a little
thought.
confused. Let me ask you a question.
So,
Simpler in terms of how it works in terms of engineering, or simpler in terms of its use.
simpler in terms of its use.
its use.
Yeah,
Okay, okay, got it.
yeah.
Uh,
Be-
and so, are you doing any comparison studies in terms of the current solutions versus your
Yes,
solution?
yes, we did see the previous prototypes,
Yeah,
and they were involved in continuous process, as I said. So
yeah,
sometimes the farmers have to perform gap filling,
yeah,
in which like they have to move the dribbler. In that case, they can't use the previous prototypes because the seeds have already germinated. The crops
yeah,
will get destroyed. So we
yeah,
are
yeah,
thinking of a mechanism such that the wheels are detachable, and the dribbler
yeah.
can be moved to the specific place to dribble.
Specific place.
Yeah,
Yeah, yeah.
yeah.
So now, I saw a similar dribbler with who was it? Mansukh Jagani, who is one of the
Okay, yeah, yeah,
pioneers.
yeah.
Uh,
Mm.
uh, the so you were talking about the previous prototypes. Who was doing the previous prototypes?
One was by Bharat Bhai.
Bharat bhai.
Yeah, in which
Yeah,
the same thing which I told, we have to just move the dribbler and the seeds are automatically placed. And another problem we faced in it was that the correct number of seeds are not placed. Like the seed rate changes every time. Sometimes it is one, sometimes it is two. So we have to, so there should be like perfection in placing the number of seeds as well.
yeah. So
Yeah.
okay, so let me suggest the following. Is there an intellectual property concern here? Are you guys trying to patent this, or what are you trying to do with?
Well, as of now, like we started with a new thing, but now we are thinking of improving the previous ones only, like getting it like the better stage.
Yeah, I see.
Yeah.
Okay. Can I suggest, since there's part of, so this is a very specific conversation that we are having, which is very useful.
Yeah.
Um, can I suggest that we so think about what is your IP strategy? Number one.
Mm.
Number two, uh, uh, let's. There are a couple of people who are very interested in this problem at MIT.
Oh.
I'd like you to connect you to them.
Wow. Okay.
Um, but you guys as a team think about uh, uh, any NDA type of agreement that you would want to have with these students, a couple of students at MIT.
Okay.
And then within that non-disclosure agreement, maybe you can exchange some design drawings and so on.
Mm.
And then have a real conversation about what are the options and all that. The
Okay.
NDA doesn't need to be any elaborate thing. I mean, it can be just a piece of paper saying, "Hey, we agree to not disclose something like this to a third party."
Hmm.
But I think we need to have that kind of conversation
Yes, sure,
for
sir.
to
Yeah,
be able
yeah.
to move forward. And
Yeah.
I do know a couple of people who would be very keen to have that conversation.
Yeah,
And
sure.
they're also coming to India actually in July August time
Oh,
frame.
nice. So,
So, sir, we will
So,
definitely like to go with this NDA. Let me talk to the professor also regarding this, and
yeah.
we will then shoot a mail to you regarding this all of this information from our side.
Okay, let's do that.
Okay, sure,
Uh,
sir.
I mean, I think an NDA would be important just so the MIT students also understand the seriousness of this.
Yeah, of course.
I'm not trying to say that they want to steal stuff and all that,
hmm.
Yeah,
but you want them to be serious about it, and I think that's the way to do it.
of course, sir.
Yeah.
Yeah.
Okay,
So let's have that conversation with your team.
Yes.
You
sure.
talk about it on your side, and let's connect further.
Okay, sure, sir, sure.
Yeah.
So we have one more
Yeah,
idea to go, right?
Yeah.
yeah, right, sir. So yeah, the
Um,
last so last one idea is about the Mauda fruit crackers.
yes.
So from the same condition as here right now. So actually, there are the four members in the team. Two are
Yeah.
at the workshop right now. Actually, they makes around 3 to 4 designs of different perspectives about
Yeah.
the mechanism and stuffs. So right now the Manthan is here from our side. He is a 12th grade pass out student, and he also regarding this working with the 15 days from last on this problem statement. So yes,
Yeah.
Manthan.
So listen.
Yes, sir. Yes, sir.
Could I connect with this team um, uh, tomorrow or something? Are they
Yeah,
around?
yeah. Of course, because maybe it's around 6. So may you have something planned out.
So
Yeah,
the reason is
yeah.
uh,
It's 6
I
o'clock.
I am volunteering for my daughter's school annual picnic, which is
Yeah,
going to travel out, and
yeah,
I can't get late to
yeah.
that
Sure,
place.
sure, sure, sir. Sure, sir.
And so, uh, uh, but I'm happy to connect at the same time tomorrow.
Of course, sir. I can make sure that all the team will connect with you from my side. I will ping you tomorrow at the same time.
Okay, and I we can Skype.
Yeah, sure, 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 sir.
Okay,
Okay,
all
sure, sir.
right. Yes, my apologies for
No, no,
the.
sir. Thank you very much for your valuable time for us. So I'm thanking you in behalf of all these summer school participants and especially from SISTI and professors.
Wonderful work.
Yeah.
Yes,
Sir, we will send you the update information of all these things, and we will circulate all this information about this, especially from the SID Dibra side.
yes.
Okay,
Okay,
sir.
let's do that. Okay.
Okay, sir. Okay, sir. Thank you.
All right. Talk
Okay.
to you soon.
Okay, yes, sir. Bye.
Bye bye.